Hi everyone, this is a second example of how to hand calculate an independent samples t-test. I'll be going through the calculations much faster because this is just meant to be a quick explanation of how to calculate an independent samples t-test. If you want a more detailed explanation, please go back and watch the first video again. If you're watching this video, that's because you think you need a little more support to be able to calculate an independent samples t-test, and you might not be feeling good about that. But here's a clip that shows somebody having to try something over and over and over again, and then finally getting it, and you feel pretty awesome when he gets it. You're like, yeah, he got it. And so, you know, it's okay that sometimes you need to keep trying at something, because when you do get it, it feels really good. Alright, I hope you're having that like, yeah, I can do this feeling, and let's go ahead and do it. So here is the sample problem. I will let you read it. So pause the video, and once you're ready to move on, unpause it. Okay, we need to state our null and our alternative hypotheses. The null is that there's no difference in how many attempts Europeans and Asians need, and the alternative is that there's some difference. So here are the formulas that you should be familiar with, and let's get cracking. Okay, I'm not going to calculate sum of squares. I assume you know how to do that. If you need a refresher, please feel free to go back and watch the first video. So we're going to jump right into calculating pooled variance. So we know that we know that the degrees of freedom for European climbers, since there's 5 European climbers, the degrees of freedom is 4. And it's the same for the Asian climbers. So the pooled variance is just the sum of squares of both samples over the degrees of freedom of both samples, and that equals 3.55. Now we can calculate the standard error of the mean because we just calculated the pooled variance, and this is what that looks like. And we're already ready to calculate t. If we know the means and we know the standard error of the mean, we can go ahead and jump right in and calculate t. So t is just the mean of the two samples over the standard error of the mean, and that means that t equals 0.67. And we can also calculate our measure of effect size, Cohen's d, and Cohen's d equals 0.43. Now we go to our friendly t-table, and we know that our degrees of freedom equals 8, so we go over here to the 8 under the degrees of freedom column. And again, you can always assume that it's a p level of an alpha level of 0.05, and it's the proportion in 2 tails. It's a 2-tailed test. So that means that our t-crit is 2.306. So our t-calc, just to remind you, is 1.25, and that means our calculated value of t is less than our critical value of t, which means that p is less than 0.05, so it's not significant. If our critical value is larger than our calculated value, that means we retain the null. and we fail to support the alternative hypothesis. And here's again a reminder of what our null and our alternative hypotheses look like. So that means that there's no difference in how many attempts Europeans versus Asian needed. And this is what that looks like in an APA-style write-up. As always, if you want more help, please feel free to take advantage of any of these resources. I certainly don't want you to feel like these 2 videos are all you have to help you figure out how to do these calculations. If you need more help, do any one of these things or more than one, until you feel very comfortable with these calculations.